Hi everyone, welcome back to my video. This is a part 2 of control structures in Java. I am Dr. Hang Ding from Indiana University South Bend. In this video, we will cover the while loop or while iteration statement in Java, and then we will also discuss two ways to formulate algorithms related to loops. One is counter control iteration, and the other is sentinel control iteration. The white statement is one of the three types of statements in Java that support the repetition structure. The white statement repeats an action or a set of actions while a condition remains true. Its syntax starts with the keyword while, followed by the loop continuation condition in parentheses, which is then followed by the loop body. The loop body may be a single statement or a block. If it's a single statement, you don't have to enclose it in braces. But if it's a block, then of course you have to enclose it in a pair of braces. This is the flowchart of the while statement. It starts with checking if the condition is true or not. If the condition is true, then it executes the statements in the loop body, and then go back to checking if the condition is still true. This process is repeated until the condition becomes false. At this point, the repetition terminates and the first statement after the repetition statement executes. Here is an example of the while statement in which the loop body is a single statement. In this case, we don't have to enclose it in braces, but it's still syntactically correct if we do. Before this loop, variable x is declared and initialized with value 3. Each iteration of this while loop multiplies variable x by 3. So x takes on values 9, 27, 81, and 243 successively. When x becomes 243, which is at the end of the fourth iteration, the condition x less than or equal to 100 becomes false, and the repetition terminates. So the loop body of this while loop executes 4 times, corresponding to the 4 iterations in which the loop condition at the start of the iteration was true. The final value of x is 243. The program execution continues with the next statement after the while statement. Here is another example of the while statement. In this case, the loop body is a block that consists of two statements. The first statement is to print out the word hi as a line of text, and the second statement is to increase a variable count by 1. The condition of this loop is the Boolean expression count less than 3. Before the loop, a variable count is also declared and initialized to 0. So what do you think? How many times does the loop body execute in this case. In both examples we have seen, the loop body has an action that eventually causes the loop continuation condition to become false. If there's no such an action, the loop will never terminate, in which case it is called an infinite loop. For example, this while loop has the condition x is less than or equal to 100, and its loop body simply prints out the value of x. It doesn't change the value of x in any iteration. So the loop condition is always true because it starts out to be true in the first iteration. As a result, it will keep printing out the value 3 and never stops. In most programs, we don't want to have an infinite loop, which is a logic error. Another common programming error that causes an infinite loop is placing a semicolon after the condition in a while statement. For example, here we want to write a while loop to print out 100 integer numbers from 1 to 100. Those numbers are stored in variable n. So we initialize variable n to 1 before the loop and use the while loop to print out the value of n and increase n by 1 in each iteration, while n is less than or equal to 100. This would work if we don't accidentally place a semicolon after the condition n less than or equal to 100. This semicolon makes the loop body empty. In other words, the loop body of this while loop is actually an empty statement. So it doesn't change the variable n, and therefore doesn't cause the loop condition to eventually become false. So it results in an infinite loop. So watch out for this common error. So you have learned the syntax of the while statement, which is quite easy to understand. The most difficult part of programming with repetition structures is not at learning the syntax of the loop statements, but at formulating the algorithm that has repetition structures. To write a while statement, you will need to determine what should be in the loop condition and what should be in the loop body. And you need to figure out those things during the algorithm design before you start writing code. Once a correct algorithm has been specified, producing a working Java program from it is usually straightforward. There are two approaches to formulating algorithms with simple repetition structures. We now focus on the first approach, which is counter control repetition. A loop designed in this approach will use a counter variable, which is called a control variable, to control the number of times the loop body will execute. Counter control repetition is often called definite repetition because the number of repetitions or iterations is known before the loop begins executing. For example, the loop in the second example we have seen was designed using the counter-controlled repetition. Variable count here is the control variable, and we can tell that the number of iterations is 3 before the loop executes. To illustrate the usefulness of the counter-controlled repetition approach, let's consider a more complex problem. This problem is to calculate the class average on a quiz where the class has 10 students and the grades for the quiz are integers between 0 and 100. The class average is equal to the sum of the grades divided by the number of students. So an algorithm for this problem on a computer must do two things. First, it must input each grade and keep track of the total of all grades input. And second, it must perform the averaging calculation and print out the result. To solve this class average problem, you could need a loop that repeatedly inputs each grade and updates the total of all grades input. In other words, the loop will implement the task in the first bullet here. And recall that before designing an algorithm, we also need to introduce variables for the algorithm. Right? So for this problem, we will need three variables. The first variable is grade counter, which is used to count the number of grades that has been input so far. And the second variable is grade, which is used to store the value of a grade that has been input. And the third variable we could need is the variable total, which is used to store the sum of all grades that has been input so far. All of these variables will be updated by the loop, and the grade counter variable will be used as the control variable for the loop. Here is the pseudocode algorithm that uses counter-controlled repetition to solve the class average problem. Note that to use the counter-control repetition approach to write the loop for the class average problem, you could need to be able to tell how many iterations the loop will execute. And yes, for the class average problem, we can tell that the loop will execute 10 times because each iteration will input one grade for one student, and there are 10 students. The grade counter variables is used as the counter as the control variable to keep track of the number of grades input so far. So before the loop, we need to initialize a grade counter to 1, and the condition for the loop to continue is that grade counter is less than or equal to 10. Note that it's equivalent to initialize the grade counter to 0 and then have the loop condition to be grade counter less than 10 instead of less than or equal to 10. The body of the loop could be to input one grade and update the total variables as well as the grade counter variable. In particular, the loop body will do 4 actions. The first action is to prompt the user to enter the next grade. And then it asks the user, it reads the input of the grade of the next grade from the user. And the third action is to add the grade that has been input to the total. And then the last one is to add 1 to the grade counter. In other words, or increase the grade counter by 1. And after the loop, The program will take the total variable divided by 10 to calculate the grade. You can store the result in another variable named class average if you want, and then print out that variable. Alternatively, you can print out the result of the division directly. Having written the algorithm for the class average problem clearly, we can now convert it into a complete Java program, which we call Java, sorry, class average.java. So to convert it into a complete Java program, of course, you have to have the import statement and need to put it in the main method of the class that has the same name as the file name. Right? And so now in the body of the main method, that's where we convert the statement in the algorithm pseudocode into the actual Java code. Recall that in the first statement, we have to set a total to 0, and then we have to set the grade counter to 1, okay, or 0. In this case, we set it to 1, and then we write the while loop where the condition would be grade counter less than or equal to 10. So it will loop 10 times. If we set grade counter to 0 initially, then here you have to change 10 to 9, or you change the less than or equal to just less than. Right? So either way it would work. So let's stick with this setting. And so in the while loops, we have four statements that corresponds to four actions in the pseudocode. The first one is to prompt the user to enter the next grade. And the second statement is actually input the next grade from the keyboard. Right? And recall that in order to input uh, the grade, which is an integer, we would have to create a scanner. So this must be created before the loop, because we don't want to create every yes, or one scanner for each iteration. We just need to use one scanner object for the entire loop. Okay, we just reuse it. And so for the second action, we just call the method nextInt of the scanner object, which is named input in this program. And then we store the input grade into the variable grade. So here we also initialize and declare the variable grade inside the loop. Okay. So I will explain later if we don't initialize grade before the while loop, then you cannot use it outside of the while loop. So here we only need the variable grade within the while loop, so we declared it inside the while loop. All right, and then after we get the next grade, we add it to the variable total. So each time we get one grade, we just add it to the variable total. So at the end of the loop, the variable total could be equal to the total of all grade input by the user. And so once we input a grade, we just increase the grade counter by 1. So here you can use the increment operator, or you can just use the simple assignment statement, a grade counter equal grade counter plus 1. So that is the implementation for the loop in the program. So after the loop, we just need to calculate the average by taking total divided by 10. Right? So recall that total and 10 are both integer. And so this division will yield an integer result. So the variable average must be of type int. and it only gives you the quotient, not the floating point value. Okay, so the fraction after the the point, after the decimal point, could be truncated, and then we just display the average, and here you can also display the total if you want. So when we run this program, it will ask the user to enter grade repeatedly 10 times. And these are the numbers entered by the user. And then at the end of, after the loop, not at the end of the loop, after the loop, it prints out the total and also the class average. Recall that the counter-controlled repetition can only be applied when you know the number of iterations of the loop when you design it. That is, before the loop executes. But in many problems, you don't know how many times the loop body will execute until the loop has completed the execution. For example, consider another version of the class average problem in which the number of grades is not known before the loop, so that the program can input grades for an arbitrary number of students each time the program runs, and then output the average grade. To solve this version of the class average problem, we'll use the second approach to formulating algorithms that have repetition structures. This approach is known as sentinel controlled repetition. Sentinel controlled repetition is often called indefinite repetition because the number of repetitions is not known before the loop begins executing. A loop designed with this approach will use a special value called a sentinel value to determine when the loop terminates. For the class average program, the loop will repeatedly input a grade, so a sentinel value for the loop should indicate the end of data entry and must be chosen so that it cannot be confused with an acceptable input value, which is a non-negative number in this case. A complete algorithm for version 2 of the class average problem could be too complex to write out right away. So we will use the top-down approach to develop such an algorithm. Recall that in the top-down approach, we start with an algorithm outline, which consists of abstract big steps. The algorithm outline for the class average problem consists of 3 steps in the sequence structure. Step 1 is to initialize variables. Step 2 is to input, sum, and count the quiz grades. And step 3 is to calculate and print out the class average. Then we will refine each step in the algorithm outline. Step 1 in the algorithm outline can be refined into these 2 steps. Step 1 is to initialize a total to 0. Step 2 is to initialize the variable grade counter to 0. These 2 steps don't need to be refined further. The sentinel controlled repetition will be used in the refinement of step 2 in the algorithm outline. Step 2 in the algorithm outline, which is to input, sum, and count the quiz grades, requires a repetition or a loop to successively input each grade. But we do not know in advance how many grades will be entered. So we'll use the sentinel controlled repetition to define this step. Okay? So this is the refinement of the step 2 in the algorithm outline. So in this refinement, we first prompt the user to enter the first grade, and then we actually read the input, which is the first grade, and but the user can possibly enter the sentinel in that case. Okay, so that means they don't want to enter any grade. Okay, and then we enter the loop. Okay, so in the loop, so this the loop will check if the user has not yet entered the sentinel value, okay, which is to signal that they don't want to enter any more input. Okay. Then within the loop, uh, it will add the grade that has been entered into the running total. Okay, so that is in the current value of the total. And then after that, it increases the variable grade counter by 1. And then it prompts the user to enter the next grade. And then again, it input the next grade, which can also be the sentinel. Step 3 in the algorithm outline, which is to calculate and print the class average, could be simply refined as output total divided by grade counter. But in version 2 of the class average program, the user may enter the sentinel value when asked to enter the first grade. So the grade counter variable can end up being 0, which results in a division by 0 when it performs the division of a total by grade counter. To avoid division by 0, we need to refine step 3 in the algorithm outline as an if-else statement, which checks if grade counter is not equal to 0, and if so, it outputs total divided by grade counter. Otherwise, it outputs the message no grades were entered. Division by 0 is a logic error that, if undetected, could cause the program to fail or produce invalid output. Now we put all of the refinement step together, and so here is the complete pseudocode algorithm with the sentinel controlled repetition for the class average problem. The first two lines are the refinement for the first step in the algorithm outline. The second part, which is highlighted here, is the refinement of the second step in the algorithm outline, and the remaining part is the refinement of the step 3 in the algorithm outline. And so now we are ready to convert this pseudocode algorithm into a complete Java program. This is version 2 of the class average program in Java. In the first part of this program, we also initialize a variable total and grade counter to 0. And then we prompt the user for the input and also read the grade. So here we tell the user to enter the grade or -1 to quit. So the sentinel we select in this program is -1, which is different from all of the valid input value for grades. And so then we input the grade, okay, or we read the input from the keyboard, and we store it in the variable grade. Okay, note that the variable grade here can be -1 if the user enter -1. In the second part of the program, we have the while loop, which checks if the grade is not equal to -1. So then we add the grade to total and increase the grade counter by 1. Recall that before the while loop, the grade value stores the value entered by the user for the first grade. And so after we increase the grade counter by 1 in the loop, then we prompt the user for the next grade and read the next grade, which may be -1. Right, so then after the loop, we write the if-else statement for step 3 in the algorithm outline. In the if part, we check if grade counter is different from 0. And if so, we output the division of total by grade counter. And here we try to get the real value, the floating point value of the division, not just the integer value. So therefore, we use a timecast operator in order to get the real value. And so just for convenience, we store the result of the division into variable average, and then we output the variable average. So here we also output the value of variable grade counter and total after the loop, uh, just for information. It's optional. And this is the else part of the if-else statement in the class average program. So for the else part, we simply print out the message no grades were entered. And so when we run the program, so it keep printing out enter grade for or -1 too quick, and then the user can enter some non-negative number. And when the user enter -1, it stop the loop, and then it calculate the total, which is 257 in this example, and it also record that there were 3 grades entered, and then it calculate the class average, which is equal to 257 divided by 3. And so know that as a good programming practice, you should remind the user of the sentinel uh, in a sentinel controlled loop. So that's the end of this video. Thank you for watching, and I'll see you again in the next video, which is about part 3 of control structures in Java. Thank you.